So you can call this chatbot. So you have that. Just a minute. So the first thing you need to think about is what kind of data are you going to train? So for example, if you're going to train on your on maybe you want to work with a company. So what you do, you take your FAQs and you convert them into JSON. And the JSON file, they will fall in a certain pattern. So we want to see that pattern, how it is. So you can just create a text file. So you can create a text file. You will save it inside where the folder is. So you will have a text file. You can use the text editor if you have something like VS Code. You can use it. If you have something like PyCharm, you can use it. You can also use text. You can use a text editor. So this, you are going to call it, you save this document and you're going to call it intents dot JSON. Okay, so wherever you are, you're going to call it intents dot JSON. So I just want to show us how we create maybe two or three of the items, and then the rest we can pick it up from our data set. So you can have your intents dot JSON. Let me just save it in my downloads for now. So you ensure you save it in the file where you're going to import it. So you'll ensure you save it in your, so if it's your DS, you save it inside the folder there. So you have that. So how we do it is that you will have your quotes, if you know how a JSON file works, and then you will pass the intents. So you will say, this is what I want. So I'll have my intents. So it's usually easier when you're writing it in something like VS Code or, you know, uh, because it will guide you on how a JSON file should be written. Anyway, that's not so I don't know if any of you has PyCharm or any. I hope you do. So you'll just say intents, and then you will call your square brackets. Okay, so how we do it is that you're going to give the items you're training in a tag. Okay, so the first thing is you're going to call a tag. Then you can say greeting. So the tag for this particular phrase is greeting. And then you're going to specify your patterns. So what does the patterns do? It will tell you how somebody can greet, so that when the chatbot receives this information, it knows hi is a greeting, hello is a greeting, niaje is a greeting, how are you, it's a greeting, what's up, it's a greeting. And then the responses will be the same. So in the patterns, that is where you specify. So you will say hi, that's a greeting. How are you? That's a greeting. Niaje, that's a greeting, and so forth. So you will specify all the patterns of greetings that you want your model to learn. The more the patterns, the better for your machine learning model. Then secondly, you're going to pass the responses. So you will say the responses. And you're going to put them in quotes. So what response? You can give straightforward responses. So you can say, somebody can say hello, somebody can say hi back, somebody can say niko poa, and so forth. So the responses are diverse and continuous. So that is how it looks. And then you're going to set the context. So you have the context set, and you can end it. So that is how the intents are organized. So any chatbot is just fed with this information. So for example, it's things about a bank. You have the tag for greeting, you have the tag for accounts, you have the tag for, different values. So that is how you're going to feed your intents.json. So for now, I'm going to give you this data, the intents.json. You're going to work with just a little. So I'll share that intent on your, I don't know if it can fit in the chat section. Let me put it in classroom. So let me put it in the classroom in a minute, and then we can proceed. So I have placed it there. So when you have downloaded it, let me know so that we can proceed. So once you've downloaded it and placed it, let me know so that we can proceed. So have you found it? Are you okay? Let me know so that we can proceed.
Yeah, yeah,
Okay,
inside download.
good. So we go to the next part. Um, we are going to do our imports. So one thing we are going to be using natural language processing because first of all we are working with uh, not numerical but text data. So we have to do what we learned in NLP in this same data set. So we are going to import the following. So you're going to import NumPy as NP. Then you can import JSON. We can import random. So these are the items you're going to use. We'll import random. We can import pickle. So import pickle. We learned about it when we were saying how to deploy a model, how you download a model. We use pickle. Then you can say import NLTK. And then lastly, you can say from NLTK dot stem. We'll say import WordNet lemmatizer. So we know what lemmatizing is. Basically, when you are learning NLP, we saw that words that have been shortened. So if it's hey, it should be hello. So it will be part of the greeting. So that is what a lemmatizer is. We looked deep through it, so I won't explain much about it. So those are the libraries we'll import. And then we can import our tensor libraries, the TensorFlow libraries, which is going to be import TensorFlow as TF. Then we can import or the rest we'll do it from TensorFlow now. So after import TensorFlow, so we'll say from TensorFlow. So from TensorFlow, import Keras. From TensorFlow, dot Keras, we import layers. We did all this when we were doing the stock item, so shouldn't give you any challenge now. So from TensorFlow, dot layers dot core, we'll import. So this is the ML we are going to be working with: dense, activation, and dropout. We worked with all this in the other model, so they should be okay now when reading them. So then we can say from TensorFlow, dot Keras dot models, import import sequential. That's the model you're going to use. We used it also before, so it should be a bit straightforward. And lastly, optimizer. The other time we called SGD, so should be also okay with. So we'll say from TensorFlow dot keras dot optimizers. Let's import SGD. Which one is not working? Keras. Oh, it should be keras. Yeah. Let's see. Let's see if it will bring it up to there. Should be working. I think we had. Let me see. Oh, is there something we had left? We can look at importing dents, but they are working. That's oh yeah. So we can take it back here. So it's from tensor. So from TensorFlow we import layers, and then from keras.layers.core we import these functions. So let's see. So from keras.layers.core, yeah. So it should be working. So that's how we import them. These two. So the first is the normal libraries, and the other one is the tensor libraries. So I'll have those two.
Mimi zangu napata errors hii mbona?
Which errors?
Import error.
Let's see.
Copy hizo umetuma. Jaribu kurun first. For the second one is okay. Unazanitumia pia ya kwanza, the first one, the first import. kwa sababu I think ilikuwa tu typos.
Okay. So those are the libraries we will need. So secondly, the first thing we are going to do is we are going to lemmatize our words. Lemmatizing means we are going to pass the lemmatizing function. So we can call a lemmatizer, then we can say equals to.
You can share your screen.
Oh, it wasn't sharing. Okay, sorry. What about now?
Yeah, that's visible.
Okay. So you can say lemmatizer equals to, we'll call wordnet lemmatizer. That's the one we imported. So we'll call the wordnet lemmatizer. And then now we can go to the next step where we will read our data. We'll read our data. So our data will be intents. So we can call it intents, which will be equals to, we'll say JSON dot loads, then we pass open, then we'll say your intents.json should read automatically, and then you'll say dot read. Okay, so you have that. Okay, so now that we have loaded our data, we are going to create some variable arrays that's going to pass the words for us. So we'll call our words. So we'll have our words in an array. Then we can say classes, an empty array. Then we can call the documents. Empty in an array. Then we can say ignore letters. Then we are going to pass, we want it to ignore question marks so that we don't have to pass those values. So you have question marks, you have exclamation marks, commas, full stops. They do not change the question for our model. Comma and full stop. So we have words, we have classes, we have documents, and then we have the letters that we want to ignore, or the values. So we want to ignore question mark, we want to ignore the exclamation mark, we want to ignore the comma, here, and we also want to ignore the full stop. So you can execute that. So those are the items we want to ignore. So now that you have that, you can say for intent in intent. So we are creating a for loop that's going to pass our word list. So we know our word list, they are already in JSON. We want to pass them inside this for loop so that they can be individually, split, and we can tokenize them. Okay, so tokenizing, we know what it is. In our NLP class, we learned what tokenizing is. So we are going to do this for loop to help us tokenize, and then we'll remove the letters we want, and we'll also lematize when they are in token forms. So that is what this function is going to do for us. So you'll say for intent, in intents, then you pass your intent. So you'll say for intent in intents, then you pass your intents. Then you'll now say for the pattern in intent, get our patterns. So we'll pass our word list. So we'll create a word list and say that word list, let it be tokenized. So you'll say NLTK dot tokenize. It's usually word tokenize, yeah, the function, yeah, not tokenize. So NLTK dot word tokenize, and then we pass the pattern. Then we'll say words dot extend. Then we pass the word list. Then you say your documents dot append, and then you'll pass the word list. Then you'll pass the intent, you pass the tag, so this word dot append takes one item. Therefore, we are going to place all these inside another bracket. So we place them inside another bracket. Yeah. So there it is. So word list, we'll just add another bracket because append takes one word. So we take the word list and the intent tag. So the specific intent tag, we want it to append the word list that we have tokenized. So we've tokenized our word list, we've extended it there, and then we want to append it to the documents. This one here, that's the tag. Then you can now say if your intent tag, say not in classes, and then we can say classes dot append. Then you can say intent tag. So you have that. So now that we've appended in the documents, you can print the documents and see how the words are now. So you can say hi, greeting, how are you? So if you had looked at your JSON before, in case you had some items, you can, so you can see, so we've tokenized them and we've now given them the response for, yeah. So there we are. Okay, so I hope you are okay. So now that we already have our words, we can now pass them, we can lemmatize them. So we want to ensure that we lemmatize all our words. So we'll say our words will be equals to, so we'll just lemmatize them. So we'll say lemmatizer, that's the name of the lemmatizer, dot lemmatize. So we are using the word net. Then you will pass each word. Then you can say, so we'll say forward, in words. So for the word in the words column, in the words, if word not in, ignore letters. So we are not lemmatizing the question marks and so forth. So you can see, for example, this one, something like the question mark here will now not be lemmatized, then will be ignored. So you'll have that. So it will lemmatize for us. Then we can sort our words. So you can say our words will be equals to sorted. Then we place the words in a set. So you'll say words. And then you can print your words. So you can print your words. So there you are. So your words thus have been lemmatized, and we've placed them in sets so that you can see. Okay, then we can sort our classes. So you can sort our classes as well, the way we've sorted our words. So we can say sorted, and then we place them in a set and call the classes. So we have that, and then we can store our cleaned end. So we can store them using pickle, the words that have been cleaned, lemmatized, and tokenized. So we can just use pickle.dump. So pickle.dump is just used to store. It will pass it as a, so you can say words, then you can say open, and then you can pass, we save them as pickle file, so words.pickle, and then have that. So we'll pick the words and also the classes. So we have that. Then we'll say classes.pickle. So we pickle dump both of them. So up to there, do we have a question?
So far so good from my side.
Pardon?
From my side iko sawa.
Okay, good. Yeah, then we can now, so we now have our clean data set. So we know when you are feeding a machine learning model, we cannot feed it in using numerical. So we have to convert, and for our case, we are going to use bag of words. We've used it before, so it's going to be quite straightforward. So we are just going to use bag of words to ensure that our model is in numerical form, and then we split it to training and testing. I mean training data. Anyway, we are not testing the model. We split it to training, train X and train Y, and then we'll build the neural network. So we'll do our bag of words. We've done bag of words before, so it shouldn't be difficult for us to conceptualize. So we do our bag of words. So bag of words, we'll call our training, and we can store it in an empty. Then we'll say out empty. We give them in terms of zeros times the number of length of classes. So we have that. So that is the training data that we want. So we will pick our document. We'll lemmatize using BOG, bag of words, and then we will output them and append them to a random shuffle. So quite simple. We'll use a simple for loop. So we'll say for document, in documents, so you remember our function there, our array. Then we'll have a bag which is empty, and then we'll have our word patterns, which we'll say equals to, then we pass the document at that position, and then we'll say now our word patterns, we want them to be equals to the lemmatized, so we'll just say lemmatizer dot lemmatize, and then we'll have our word dot lower. So in case it's typed in lowercase or uppercase, it does not make any difference. So because all of them will be lowercase anyway. Okay. Then we'll say for words in our word pattern. And then we'll now say for word in words, then you'll say bag dot append, then you pass 1 if the word in the word patterns, else we append in the bag of words. So we'll say bag dot append, then we pass it there. So we'll execute that. So we want, then once we create that function, we'll do the output. So what it should give us, so we can say output, we can say output row will be equals to the list, and then we pass empty, and then you can do your output row, then we pass the classes dot index, classes dot index, so we list the indices. We'll say it will be document from position 1, which will be equals to 1. And then now we can append our training. We'll put the bag of words, so the bag plus the output row. So we have that. Is there anything that I have missed? Oh yeah, so this one we'll put them in square brackets. So we have that. So our data now is there, and it will be in terms of the bag of words. So you have that. Then we will randomly shuffle the data set so that it's not trained in one continuous order. So we will randomly shuffle, we place them in an array, and then we will do a split, train test split. So we can now say here we have the random random.shuffle, then we'll call our training. And then we'll say our training equals to, we'll say np dot np.array, then we call the training data. So we make them an array, we convert them to array format. We all know that when we were doing the stock market, we had to convert our data set to an array so that when we now do the train X and train Y, our neural network model can learn. So we have that, and then we'll do our train split. It's not the train test, because what we are doing, we are training fully our model with all the data that we have. We know in neural networks, what we do, we maximize on the data. Okay, so you can say train. So our X train, we can say, is going to be list, and then we pick training. So we'll pick that, and for our test, we'll do the same. Train Y, not our test, our Y. So we have our X and Y. We train with X and Y. We pick 1. Okay. So this is in form of arrays, because we know our neural network models reads in form of arrays. So now that we have our training and our testing, so you can have that. Okay, so up to there, do we have a question? Up to there, do we have a question?
No, no.
None from me.
Okay. So next thing is now training our neural network model. So we can say model training. So we can train our model. So for neural networks, we know so we'll use so train, it's just similar to what we did last time. We are going to call our model. So our model, we had imported them up there, so we don't have to do that again. So we can say our model will work with sequential, and then we understood how the neural network framework works. So we begin with the how much you want to train it with, the input shape that you want to use, and the activation function. Then we do the dense, we do the dropout, we do the dense, we do the dropout. So depending on how many layers. So here we are going to give it 2 layers of training. So that's how we are going to do it. So you can say model.add. So you'll do dense, then you'll pass the number, you'll do the input shape from our dense. So the input shape here will be the length of the training set. we've shuffled them randomly so that we don't know. Here we also have a little data set, so we cannot specify the way we specified last time. We want our data to begin from training data to be 50, testing to be 10. So here we'll just give the length. So the input shape, so we'll not specify it because we don't know the data. So the shape will be the length of what? Train X values. So train X values. Okay. And then you can say comma. We'll have our activation will be equals to relu. So it's an activation function for rectified linear unit. So you have that. Then after we train it, we go back. So we'll do dropout, go back. So model.add our dropout function, which is just going to be 0.5. So we do 0.5. Then we'll do a dense. So we'll say model.add. So we can retrain with train with 64. And our activation, we can ensure it's the same. So we can say activation. We use relu. So this is the second layer, first layer, our second layer. And then we do our dropout. And then the last one, we do the train Y. So we'll do the last layer. So you'll say the layer model.add. Our last one will be, we are using dense. Then we'll say let it, the input shape, that's the first one. You don't have to write input shape equals to, you can say the input shape will be train Y. That is the length of train Y. And our activation here, we're going to use softmax. So you have that. Then we can run that. Is there anything we've missed? Here, yeah. Should be here. The int part, where is it? Where is it? Where could the issue be? Let me check. Yeah, so I think run it again. I think now it's okay. I think I had missed a square bracket. So can have that. I can also share this model in the chat in case you need some assistance on the same. So you can have your model. So have that. Okay, so I hope we've all trained our model.
Yeah.
Yeah.
Okay, good. So the next thing we want to do, we want to call the optimizer. So when we were working with it was the Google stock. We looked at Adam optimizer. We looked at how is it called? The SGD. We looked at it. So let's see. We can do a model dot compile, and then we can say our loss. So our loss function, the other time we were using MSC, but then we know that right now we are not looking at data or something, numerical data, which we want to see how it has performed. So we are going to use a loss function called categorical cross entropy. You can go read through it. So categorical cross entropy, that's the loss function you can try and use. Then we'll have the optimizer. So you can tune an optimizer to your best setting. So optimizer, let's try CSGD. And then we have the metrics. We can also try and tune it later on and see. So we'll say metrics. We want it to give us the accuracy. So how accurate is this? So we say the accuracy. So there we are. So we'll use the SGD. Our metrics will be accuracy. And yeah, then we can now do a model.fit. And yeah, we train our model. So you can say we use arrays in terms of data. So you will have to pass them in array form. So we'll say train X in form of an array. So you can do it kando and say array X and array Y. Yeah, I think we can do so that the fit is not so. So we convert them into array. So we say array X is going to be equals to numpy, which is np dot array, and then it's going to be train X, and then we'll say in terms of Y, X and Y. So array Y, which is our responses. Sorry, array Y, then we say train Y. So we have them in that form. And then we can fit our model. So we'll say model.fit, then we'll say array X, our array Y. So our data, that is our category, the category and the letters, not letters, category and information. And then our Y is the responses. We talked about epochs. How long do we want it to be trained? So you can do 100, 250, depending on how you want your data to perform. So we can do maybe 200. You can begin with 100, and then we can do our batch size. I had talked about this when we were doing the stock. So we know batch sizes, and then we can say variables equals to 1. So then our model will train. So you can see it will train. You can see the loss function is getting low. We can see the accuracy was fluctuating, but then as it continued to train, it became more lower and lower. We can see the loss function imeenda chini chini chini. At around 183 imeshafika 0 point something, and the accuracy is 1. So the more you train the model, the better it becomes. So this is lightweight data. If you are to train it with FAQs of a company, then you don't expect it to be that fast. So it will take some time to train. So you can have that. And there, so I think that is what I had planned we do up to today. Today it has been a bit smooth, so we don't have so much. So now that our model is trained, so I can pick questions. Any questions?
I have a question. When it comes to now the deployment of this, are you supposed to take us through it, or we have to find it out on our own?
Deploying it in what way?
See, it's supposed to be a chatbot.
We are going to let me respond to that. We are going to see how it chats, but I'm not going to do the HTML part and CSS. Okay.
Yeah.
So what it means, we are going to predict, and we are going to see, we are going to do we are going to run functions, and then we are going to chat with the model. But the part where you now come up with a user interface and all that, that one you'll now have to strive more, go learn a bit. But we are going to, so the next part, which is tomorrow, we are going to be able to chat from PyCharm using functions.
So
Okay.
thanks.
Just a minute. So yeah, any other question?
No, iko sawa.
Okay, sawa. So I think that's it. So you can go and digest maybe what we've been able to do today. Then tomorrow we'll now come to the second part, where we'll be doing predictions. Rather, we'll be taking in data from a user so that the chatbot is able to respond. Okay.
Okay.
Monday ikifika wewe mama akipata dosi utampatia tukuongezee.
Sawa.
Okay, thank you, and I'll see you guys tomorrow.
Haya, you too.